I get the quizzes in. Alrighties, and cool, we're good to get started. Let me, okay. What's up, everyone? Yeah, I know, let's see, it's like raining so hard today. I don't know, because maybe y'all are just staying at home since you have online discussion anyways, but I was like, I got up at like 6:30 because I wanted to eat breakfast with my friend, and then I just looked outside. I had slept kind of late, and I was like, oh man, I'm really gonna regret this if I eat right now. And so I had to flake and be like, I'm really sorry, I can't wake up. But yeah, it's like, there's like so much rain, and clearly I am exposing myself as I say that because I am from SoCal where I barely see any rain. And so it's wild. I say that every week too. But yeah, so hopefully you're not getting too wet from the rain. Hopefully you're not getting sick from the rain. Let's see. So today is November 16th. We're gonna be talking about SQL today, and we're pretty much wrapping up the course at this point. I mean, once you turn in Scheme tonight, or when you finish it, like after that, it's the aggregation lesson, which is like part 2 of Scheme stuff. So today is kind of like the fundamentals of Scheme, and then we'll be talking about the more difficult parts in lecture. And so, yeah, I think it's a good time to have a really good break during Thanksgiving, and then once we come back, it'll be the final review, because that'll be like the last week of class, and just be like the last hurrah before finals, and then it's like the end of many of your first semesters here, which is kind of crazy. And so I just want to say that there is no lab and discussion next week. Discussion is canceled because we don't have school, but lab is just canceled because I think attendance was low, and we just decided to cancel lab anyways. I believe we have our homework out, and that's our SQL homework. I don't think we have any more after this. Excuse me. And yeah, I'm pretty sure we don't have any more, and if we do have any more, it's like a survey or of some sort, just based upon like previous iterations of the class. So this is like your last homework, which is like, so exciting. There's so many exciting things that come when it's at the end. So yeah, and Scheme is due tonight. I'll be there from 7:30 to 8:30 if you have any last minute questions or are just bored on a Thursday night and want to come hang out. And next week is Thanksgiving, so I'm really excited. I won't be having, like I said, there's no lab next week, and so I won't be able to see you all through the camera or like talk to you. I mean, we can still chat on Slack. But happy Thanksgiving. I hope you have a really wonderful break. And please do take some time to like not do anything, because once you get back, it'll be the last grind, So do take some time to take a break. And I just want to say that we will be learning about like more difficult or more complicated ways to use Scheme, I guess. That's the best way I can put it right now. And so don't ignore those things completely, for sure. But yeah, I don't want you to think that, oh, this is all SQL can do. Like we just do like I think in this worksheet we do fairly simple things compared to what you can do with SQL, and so watch out for that on Friday. But with that, does anyone have any questions, like logistical questions? Oh, something that someone asked me was, how can I check how many participation points that I have? And so if you want to know this, we don't currently have a feature on OK for you to check, but you can look at the labs on OK, how many quizzes are on Gradescope, and then you can message me on Slack and ask me like how many checkoffs do I have if you want to calculate the number of participation, and then of course excess participation points make recovery points. So if you want any of that information, just let me know. Let's see, did anyone else have any other questions? I don't think so. But yeah, does anyone have any questions for me? And I see a chat. What is the main emphasis of the final? Very difficult to say. I don't know if I can answer that question. You can, I think there's like, common themes that you can see when analyzing past finals. I think to prep for the final review discussion, I'll try to also look through those, but I can't really say anything about what is the final emphasis. I mean, yeah, and like the reason for that is like people will only study what they might say. Will there be more emphasis on what's after midterm 2? I mean, this is my opinion. So from when I took the class and from when I look at the practice finals, it looks like there's a little bit more emphasis on what is after midterm 2. That's what I can say. But I also think that a lot of what we learn does build on each other. Yeah, of course. Good question. Any other questions? Okay. All right, then with that, let's get started with SQL. This discussion we'll get through, I am almost certain, like 100% certain that we'll get through all the questions that are like required, and then I think we'll just cut it off any early if we do end early. Yeah, just to give everyone a little break. But with that, let's start. So I'm gonna pull up my, also it's funny, like after, what is it? After, oh my God, it's been 10, 11 weeks of doing discussion in this room. I have finally learned how to like move this tablet thing down that I'm writing on. I had no idea how to do it until today because I was just like, oh, what does this do? I thought that was funny. I also learned how to like make this desk move up. So great. Okay, let's get started. Okay. So I'll just be talking through this today. So SQL is yet our third language that we're learning. It's Python, Scheme, and SQL. And it's an example of, it says, a declarative programming language. And you might be wondering, okay, what does that mean? So the languages that we've been working with in the past have been like, you know, something like Python is like, we do something like def, function, do this for like, you know, x, oh well, this is not code at all, but it's like, yeah, while x is less than 5, like print high, right? Something like that. And so languages like Python are describing these computations directly. That's what they mean. It's like, this is the computation that I'm performing. Whereas things like SQL are like, they're not saying like, oh, do this like this. They're just saying, hey, I just want these tables, or I just want this information. And so if you look down here, our data is organized into tables. And these are the tables that you've probably seen in other classes and, you know, have familiarity with. They have your columns, your rows, and your values. And we can look at this table down here. You'll notice that it says 9 rows. This is actually 8 rows. Sad, because there's not 9, but it's all good. So yeah, there are 9 rows here. There are 8 rows here, and there are 1, 2, 3, 4, 5 columns, right? So just so we can get quick up to speed with any terminology, right? 8 rows, 5 columns, and there are 40 values. And I did that by doing 8 times 5. Make sense? Yeah, we're pretty comfortable. I think in general people are pretty comfortable with this idea of tables. It's not something like super strange like streams, which I think is a bit more abstract, definitely, than tables. But with this introduction, I want to show you a few things, like the fundamental things that you can do with Scheme. SQL, sorry, not Scheme. And so let's go through these. There's a lot of keywords in SQL, but I think that they're a little bit more intuitive to remember. And so select, right? It says select is used to create tables. And so you'll notice that we selected Ben, which is an entry from the table. Oh, sorry. That's not true. We selected Ben, and we made it a value under the column first, and then we selected Ben bit diddle and then made it value under the column last. So we're creating a table here. And things that you can do is, like, if you want to make a larger table than just Ben bit diddle, because, you know, well, maybe you want to keep track of more data than just one person's full name, you just use union, right? Which kind of makes sense, right? Because union means to put things together. Not to be confused with join, with how to join tables, which we'll be talking about sooner. But union just puts together, union just combines rows, right? So let's I know you have it like right down here, but why not? Let's just summarize. So this creates tables, I guess, as designates column names, something we don't explicitly say. And union, it's not the same thing as join, and this combines rows. And so one thing to note about these two tables is that these are like temporary. In the sense that you haven't saved them and you can't access them. And if we want to save a table, well, we use the term create table. So we'll add that to our list of keywords, right? Create table saves the table. Cool? And you'll notice that within create table, oh, sorry, I guess as just designates a name to something else. I'm going to change that here. I'm just going to say designates names to like object, maybe. Object being your column or your table. Yeah, so you'll notice that we still use the select statements in here. We still use our as statements and all that jazz. It's just that now we're saving the actual table. Cool? So once we have a table, or if we're given one, then we can select rows from these tables, right? And so this is still the same select that we used when we made the ben bit diddle table. This is still the same select keyword we learned above. But now it's being used to select certain columns from an existing table. And note, from an existing table. So this table is not one that you've, like, this is something that already, yeah, an existing table, yes. And so if you look at records, this is like ... right? This is not the full table, but you'll notice that we get the name and the division. So we get Alyssa Hacker, computer, Ben Bit Diddle, computer, et cetera, et cetera. Cool. Is it clear how we got the tables, the rows from the existing table? Nice. Okay. And then you might have seen this asterisk before. So we see it when we say something like args or like import star, something like that. Which just definitely, it just basically means like all, right? Like args allows you to put in like multiple arguments. So in a similar sense, select star selects all the columns from a table. So let's go back, and I'm just going to put a little like note. Select star takes, yeah, selects all those columns. Yeah, and I know that the terminology of columns and rows is probably like something that you're used to, but be really careful. Like when you're working with a lot of tables, I think it can get confusing because you might like accidentally mix up like the column and the row. So just do be really precise with like what you're calling things and what you're referring to. Yeah, so that prints all the contents of the table, right? And what's different from this records and this records? Well, this one only selects 2 columns, right? So this only selects 2 columns. 2 columns. Okay. And then this is like the general syntax for SQL. We can have more clauses, and we will be learning about, sorry, clauses are these key bolded capital letters here. We can have more of them, and we will be learning about more of them, but these are like your basic ones, the ones that you need to do like general things. So selecting columns, and then from tables, where, condition, order by, all that jazz. I think a common question that we get is, how do you know like what order to put the clauses in? I think that comes with practice. I also know that I don't want to say too much about it right now because you haven't learned about additional clauses that you could be using. But for example, right, we can't say something like from table, like, yeah, I'm pretty sure you can't say something like from table select columns because SQL needs to know where it has to select the columns from. But I think that these are interchangeable, like order by and where condition. But keep in mind that like sometimes the way that we word the problem will like give you a hint as to what might be the best way to order the clauses. And in general, I think the ordering of the clauses is not too big of a deal. But I know when you're first learning this, you might just be like, oh, wait, how did we know to put where first? The way that I like to think about it is kind of like going from general to specific. And that's not always the case. But that's kind of like a general guideline that I follow because like generally it's like, oh, I just want all my data first, right? So I'm going to do select and select columns and then from a certain table. And then I'm going to like sort this by a certain condition. And then ordering is kind of like a very specific thing. Like how do I want to sort my table? So that's kind of like the way I think about it. But like I said, it's not too big of a deal. Yeah. And so here we learn about a where clause. So where filters rows. Filters rows. And order by sorts them. I also want to say that when we learn about additional clauses on Friday, there are some clauses that like definitely have to come together or have to be used in pairs. For example, like where and order by don't have to be together. Like you can say just select from and where, and you'll see that in an example later. But things like you'll learn about having in aggregation. I just want to do a quick point. You haven't learned about it yet, but you will on Friday. And in case you do get confused, something to keep in the back of your head is that, so on Friday, you're going to learn about aggregation, and you're going to learn about this clause called having. And I think this is definitely a point of confusion, is like, what is the difference between where and having? Because it sounds almost similar, like where like this certain condition is fulfilled versus like having this certain quality. And I just want to say that having is used to filter groups, which you'll be learning about. If this doesn't make that much sense, it's okay. But once you go into lecture or watch it, this term will come up, and then you'll be like, oh yeah, like what is the difference? This one is used to filter groups, whereas where is used to filter rows. And having is to be used with this keyword called group by. So just some things to keep in mind. Okay, cool. Any questions about like all the different kinds of clauses? And let me check the chat in case anyone is sending anything there. Okay, seems like people are okay. I'll give it maybe about like 20 more seconds for just everything that we've talked about to sink in. Okay. And you'll notice that this is an example of the syntax that we're using. So we're selecting all columns, right, because that's what the star means, from this table where my title is a programmer. So in the case of our example, like let's kind of translate this to English. It's like, I want all the people who are in this table records who are programmers, right? That's what we're saying. And again, like this idea of declarative programming is like, I'm not specifying like, oh yeah, for this column, like loop through and then match, you know, like I'm not telling the computer what to do. I'm just telling it, hey, I just want these things, and like give it to me. Yeah? So it's powerful. It's powerful to just be able to tell the computer what you want instead of having to program, like having to tell it how to do it. Okay. And then another thing that you might want to know is just that you can sort in descending order by adding a negative sign. And I believe if you don't put the negative sign, it sorts in ascending order. So cool. One more thing that you might want to note is that all valid SQL statements have to be terminated by a semicolon. And it also goes on to read something about how, you can split up your statement over however many lines, and like also in Scheme, you don't need to worry about the amount of white space. Like for example, in Python, right, like your tabbing has to be a specific amount of spaces and all that jazz, but it doesn't really matter in these languages. But keep in mind that like, sure, not having consistent spacing is like, it doesn't break anything, right? But there's a lot more to programming than just like, is my code broken or not, right? Like when you work with other people, you want to make sure that they can read and understand your code effectively and quickly so that you can work on things together. Cool. And your future self, of course. Yes, I have definitely made mistakes. I have definitely thanked my future self at times, and I've definitely also been like, my future self was so dumb. Or my past self was so dumb, I mean, because my future self is now suffering because of what I've done. But anyways, yeah. So any questions about Scheme in general?
Is there a way to order by alphabetical order?
Yeah, great question. So if you want to order by alphabetical order, we'll be doing that in 2.3, but you can just do order by, so the reason why this one orders by salaries, by the numbers, is because the values in the salary column are all numerical. Whereas if we wanted to do something like order by name, it would automatically do alphabetical ordering because that's the ordering it understands. Does that make sense?
Then how do you do like reverse alphabetical or something?
Yeah, so reverse alphabetical order, I believe that doing order by negative name works because it just understands that it wants to flip the order. But I will either try it out myself or I can send you the like, you can just make a really quick table with like 2 lines or something and then see how it sorts it. Because there's like online interpreters for SQL. Yeah. Good questions. Any other questions? Alrighty, so I'm going to give you 2 or 3 minutes to do 2.1 to 2.3. Maybe about 15 more seconds. Unless someone would like more time, then that's fine. Okay, so what do we have? Can someone, I think these are short enough and not as intimidating as maybe past questions, and so I'm gonna have someone give me their like queries here. So what about the first one? What did you all put? You can type it too if you would like.
select name from records where supervisor equals Oliver Warbucks.
Yep, so select name from records where Oliver Warbucks. Cool. And then what about the next one? Oh, and don't forget your semicolon. And sometimes, I know some students get stuck on homework for a long period of time, and then it's just like they forgot a semicolon. So don't forget the semicolon. Sorry, go ahead.
Select asterisk from records where name equals supervisor semicolon.
Cool. Select, what is, from records, right, because we want to output all from records because we're working with this table, where supervisor is equal to name or name is equal to supervisor. That's fine. And since we're checking to see if it's equal, we're doing equals equals, similar to how we check to see if things are equal in Python. And semicolon. And then what about the last one?
Wait, why is there a double equal sign where the one above it just has the single equal sign?
Oh, great question. Wait, did I? Let me just make sure. Actually, I might have added a. You are correct. Sorry. I just have a bad habit of putting double. Yes. And then what about 2.3?
Select name from records where salary greater than 50,000.
Mm-hmm. So select name. Salary is greater than 50,000. And then I think you might be missing something. Let's read the query again. So.
And then order by name.
Right, order by name. Cool. Any questions on this? Alrighty, so let's talk about joins. And to do this, I'm gonna draw, yes, I will draw a small table. So SQL is really powerful because we can do a lot of cool things with tables. And the thing that we'll be talking about is join, I guess specifically the inner join, but we just call it the join in this class. And so it says, when tables are joined, the resulting table contains a new row for each combination of rows in the input tables. And so if the two tables are joined and the left table has m rows and the right table has n rows, then this joined table will have m times n rows. Which is like, okay, that kind of makes sense. Like, sure, I can see that they, multiplied the m rows with the n rows. But if you remember back to your lab, I'm pretty sure we talked about join there. We have, I think, a pretty good diagram, if I'm not mistaken. I'm gonna check really quick. Yeah, a good diagram with the select the table football and then table football, so the two tables that we had with about Berkeley and Stanford or what have you, and we joined those two together, and then you can see the illustration of what happens in the joining process. So I'm going to do that, but in a much smaller example, in a much smaller setting. So we want each combination of rows in the input table, right? So what does that look like? Well, let's say that we have, I'm just going to write it out in table format because I think that you can form the queries for these tables. But let's say we have a table named color, and we have apple and orange, and red and orange. And then we also, so let's say this is table 1, and let's say this is table 2, And let's say this table is called radiation. And let's say that we also have a fruit column and a rads column, like for radiation. And then let's say that these are the numbers that we have. So apple receives 0 radiation, and oranges receive 30, okay? And so just a quick reminder that if you want to actually create these tables, you would have to do create table color as, and then select the column, put in your value, et cetera, right? So if you want to join this table, a really simple join we could do is something like select from, I should put them in all caps to be consistent. Select star from color and radiation. And what will this give you? Well, the resulting table will be this. I can't spell apple. Okay. Apple. And then this would be orange, 50, oh, 30, sorry. Right, so these are all the possible combinations for these tables, right? And is it accurate? Yes, because we have m rows and n rows here, so we have 2 rows and 2 rows, and then we have 4 rows in this resulting table, right? So you'll notice that we took the apple and red column, sorry, apple and red row, look at that, apple and red row, and then we matched it with these 2 options, right? Because we have 2 rows that we can combine it with, and then we did the same thing with orange. Any questions on join? And one thing I want to point out about the syntax is that the comma is used to separate the table names when you're joining, and the semicolon, I feel like we're in English. I love English though, so. But yes, the semicolon is the end of a SQL query. So let's just put that, let's just jot that down the side somewhere so that you, so that you remember. Commas used to separate table names when joining tables. And then semicolons, it's just the end of a valid SQL query. Cool? And one more thing about tables that we can do is sometimes you want to join the same table, which we did in lab. So how do we differentiate between the 2 tables? Well, we can just give them aliases. Used to call this, say this as aliases, or I was like, how do you pronounce this word? But I think it is aliases, right? Yes, but SQL allows us to give aliases to tables within a from clause using the keyword as, and then refer to a column within the particular table using dot expression. So like, oh, what does that even mean? What does that even look like? Well, I think this example puts it pretty simply. So remember, this is records, the table that we're working with in the previous problem. And we can give it like a, kind of like a temporary nickname, like, oh, let's say that one copy, or yeah, let's refer to like the same table, but like have like essentially like 2 copies of the same table. And then we have records as A, records as B, and then you'll notice that we select, or we refer to either A or B, depending on what we want. Maybe the dot notation reminds you of like attributes from objects, and I guess in a sense, right? It kind of, not really, because it's not like this is necessarily like an object, like the same way it is in object-oriented programming. But I guess it's not completely inaccurate, right? Because it's kind of like it's like a table's column. It's like a table's like attribute or characteristic. So, I don't know. Maybe the dot expression is just some sort of like universal way of understanding like characteristics. I'm not sure. But anyways, just wanted to point that out. So with that, does anyone have any questions about join before we try the questions? Okay. I'm gonna move this down. And so now we have two tables. Yes, we don't give you the like full-on data, but I think it's nice that we provide, now you don't have to keep flipping back and forth because we used to not have these tables and it was like, yeah. So now we have these tables. You can look at the column names that are in here. In general, when you're writing queries, one, what's really important is you need to read the statement. Reading is a lot harder than it looks. Like reading carefully, I think is pretty difficult. And so make sure you don't just speed through. Don't assume that you know like what it's saying. So read the query, one. The second thing you want to do, especially when you have a feeling that you might need to join something, is get a general idea of the table that is formed. You might be wondering, okay, how do I know when I want to join two tables? And to put it simply, it's like when one table is not sufficient information. That's like my one way I can describe it to you. And then the last thing is, so you read the query. I'll just write these steps down because why not? Read the statement, the problem statement. Carefully. And then the second thing is you want to think about the general idea of the table. And then third thing is like think about what data you're wanting to extract. And that kind of goes hand in hand with like point one. So with that, I'll give you about 3 minutes to do 3.1 and 3.3. And then we'll go over them.